So, um, you know that feeling when you're like deep into using an app on your
Oh,
phone?
yeah. Usually when I'm in a rush, right?
Exactly. Like maybe you're navigating this massive checkout process for concert tickets or, trying to save a document you just spent 20 minutes typing with your thumbs.
Right. And you're just praying it goes through.
Yeah. You hit confirm and suddenly the screen just freezes.
Mm.
The UI completely locks up.
The absolute worst.
And then like a second later, you're thrown right back to your home screen. It's just a nightmare. And avoiding that exact scenario is basically the entire reason mobile application testing exists.
It really is. I mean, think about the logistics for a second, right? With the sheer volume of different device models out there.
Oh, it's staggering.
Yeah, varying screen sizes, constantly updating operating systems and, fluctuating network conditions.
Mm.
Testing all those permutations by hand is mathematically impossible.
You'd need an army of people tapping screens for decades.
Right. Which is why relying on human testers to manually tap through every possible user journey on physical devices is fundamentally broken. It's too slow and it misses edge cases.
And in today's rapid release environment, it's just financially ruinous, right?
Exactly. To detect defects early and actually protect a brand's reputation, automation is pretty much the only viable path forward.
Which brings us to the core of our mission for today's deep dive. We're going to break down the technical landscape of mobile test automation so you can figure out the exact right framework for your team's next app project.
Yeah, it's a huge decision.
It is. So we're pulling all of this from some incredibly detailed technical breakdowns by Apple tools alongside these comprehensive software testing architecture guides from Geeks for Geeks.
Both are fantastic sources. And I think the best place to start is at the foundation. Before we can test everywhere at once, we kind of have to look at the tools built by the platform creators themselves.
Right, Google and Apple,
Hmm.
because obviously they don't want buggy apps on their storefronts either.
Exactly. So they provide developers with native, highly optimized testing frameworks. And for the Android ecosystem, Google's definitive answer to this is Espresso.
Espresso. Okay, so according to the Geeks for Geeks material, the defining characteristic of Espresso is just raw speed. But I really want to unpack why it's so fast.
Sure.
Because it's not just running the same code on a faster processor.
Yeah.
It's about how the framework physically interacts with the application.
Yeah, that's exactly it. Espresso actually synchronizes its test actions directly with the user interface without needing any server
Oh,
communication.
wait, really? Directly with the UI?
Yeah, that synchronization is the real magic here. In older testing frameworks, a script might click a button and then have to artificially, sleep or wait for a set number of milliseconds.
Hoping the next screen loads in time.
Right, which was incredibly inefficient. But Espresso doesn't guess. It ties directly into the Android main thread. It knows the exact microsecond the user interface is idle and ready for the next interaction.
So the feedback cycle is instantaneous. That's wild. The test code and the application code are essentially living in the exact same environment then.
Precisely. And because of that, the sources know it requires the entire code base to run. It makes it a really powerful gray box testing tool.
Okay, gray box. So it's not a complete black box where you're just poking at the outside of the app.
Right.
But it's also not a pure white box where you're just running unit tests on raw logic.
Yeah.
It's got this driver backdoor capability.
It does. And because it sits right there inside the code, it uses very specific Android mechanisms to find what it needs. For instance, it relies heavily on the id from R file locator strategy.
Okay, let's break that down for the listener because that sounds like heavy developer jargon.
Yeah, it does a bit.
The R file in Android development is basically an auto-generated index.
Right.
It maps all the visual resources, every button, every image, to specific integer IDs in the code.
Exactly. So Espresso isn't looking at the screen visually. It's
Yeah.
just scanning that internal directory to instantly grab the element it needs.
That's so smart. It's basically using the app's own internal map. And to actually interact with those elements, the sources mention Espresso uses something called hamcrest matchers.
Ah, yeah. Hamcrest matchers.
I see that term constantly in Android documentation. A matcher sounds simple enough, but how does it function in this context?
Well, Hamcrest is a framework for writing software rules. Instead of writing complex nested code just to see if a button exists, developers use these matchers to write test assertions.
Like assertions that read almost like logical sentences.
Exactly. You can tell Espresso, find an element that matches this ID from the R file, ND has the text submit, ND is currently visible. It lets the tests filter through the app's layout instantly.
Okay, let's unpack this. Because using Espresso feels like having the ultimate home field advantage.
Oh, for sure.
You know the stadium perfectly, you can run blazing fast, but you have to speak their specific language, Java or Kotlin for Android.
Right. And what's fascinating here is that while these tools offer unmatched speed, they completely lock you into a single ecosystem.
Yeah, because if we jump over the Apple ecosystem, we're looking at a completely different stadium and a totally different tool, XCUITest.
Yeah, Apple's approach with XCUITest takes a distinctly different path than Google does with Espresso, built right by Apple, inside Xcode.
But it doesn't live inside the app the way Espresso does.
Yeah, it doesn't. It runs in a completely separate process from the main iOS app.
Okay, so it's relying on inter-process communication. Like the test script is essentially a separate app that's just shouting commands over a fence at the main app.
That's a great way to put it. And that separation provides a very stable black box testing environment. Because it's outside the app, it can't just use an internal map like Android's R file.
So how does it find anything?
Well, XCUITest navigates the application using accessibility identifiers. It interacts with the UI through the exact same accessibility layer that features like voiceover use.
Oh, wow. That makes a lot of sense. So the test is saying, hey, iOS, find the element that you've labeled checkout button in the accessibility tree and simulate a tap.
Exactly. It's interacting much closer to how a human, or at least the operating system acting for a human, would. Plus, it has these robust inbuilt assertions, like XCTKVO expectation.
Okay, wait. KVO stands for Key Value Observing in Apple's World, right?
Right.
So rather than constantly polling the screen to see if a loading bar is gone, this assertion allows the test to just watch a specific variable in the background memory.
Yes, exactly. The moment that variable changes state-like from loading to complete, the test immediately fires the next step. It's highly efficient for Apple hardware.
And crucially, the sources point out that if team is jilting for Apple TV, XCUITest is the only reliable way to verify tvOS apps.
Yeah, the platform integration there is just unmatched.
But here's the elephant in the room. Writing tests twice sounds like a massive headache.
Oh, it's incredibly painful.
If a company is building an app for both Android and iOS, relying purely on native tools means you have to write every single automated test twice. You need a Java team and a Swift team.
Right, you're duplicating effort, duplicating maintenance. It significantly slows down the release cycle. So what if you want to write your test code once and have it work on both an iPhone and an Android?
Enter the cross-platform solution,
Right.
which the Geeks for Geeks guide heavily focuses on. We're talking about Appium.
Yes, Appium. It's an open source, community-maintained framework, and its flexibility is its biggest selling point. You can test native, hybrid, and web apps without modifying the app code.
Let's dig into how it actually works, because the architecture is really clever. It follows the Selenium W3C protocol.
Right.
For listeners who haven't dug into web drivers, that basically means Appium operates like a web server using a standard REST API.
Mm.
So you can use Java, Python, Ruby, C#, JavaScript, like whatever language you prefer.
Exactly. That script sends standard HTTP requests to the Appium server. And here is the really cool under-the-hood secret of Appium.
Oh, I love this part.
It doesn't reinvent the wheel. It actually uses Espresso or UI Automator 2 and an XCUITest as its backend.
Here's where it gets really interesting. Appium is just giving you a universal remote for the wheels Google and Apple already built.
Yes, it's a stable WebDriver interface sitting on top of those native tools.
So if I'm testing an Android phone, my Python script talks to Appium, and Appium quietly hands that command over to Espresso or UI Automator 2 to actually execute it.
That is the exact flow.
Hmm.
And for iOS, it translates the command and hands it off to XCUITest.
But I have to ask a pushback question here. Doesn't adding a universal remote layer slow things down compared to raw native speed? We just established Espresso is blindingly fast.
Well, yes, there absolutely is a trade-off. Because of that network overhead, Appium isn't going to execute a microinteraction quite as instantaneously as a pure native Espresso test.
Right.
But, the massive gain in cross-platform code reuse usually makes it the best choice for hybrid environments. For a standard banking or retail app, that tiny fraction of a second overhead is totally negligible.
Yeah, that makes sense. So, okay, now that we've written our test scripts in Appium or Espresso, where do we actually run them?
Right, because running them on the single phone on a developer's desk doesn't reflect the fragmented real world.
Not at all. I mean, historically, developers relied on simulators and emulators running locally on their laptops, like Android virtual devices or browser-based emulators.
And those are great for initial sanity checks. They're fast, they're free. But a simulator is just software mimicking hardware.
Right. It can't accurately reproduce how an app will drain a physical battery
Mm.
or struggle when the CPU is thermal throttling on a hot day.
Exactly. To get true confidence, you need real device testing. But procuring and maintaining a physical room full of hundreds of phones is a huge financial burden. This is where cloud platforms like Lambda Test come in.
Okay, Lambda test. So what does this all mean for your workflow?
Well, Lambda Test is an AI-powered test orchestration platform. It provides a cloud-based device farm giving you access to real Android and iOS devices, plus the emulators.
So wait, if I write my script, I can plug it into Lambda test, and suddenly my app is executing parallel tests on 100 different iPhones and Androids at the exact same time.
Yes, that's the beauty of it. And platforms like Lambda Test integrate directly into CI/CD pipelines like Jenkins or GitHub Actions.
Oh, wow. So testing becomes continuous.
Exactly. It's highly scalable without a company needing to buy and maintain that physical room full of phones. The moment a developer pushes code, the pipeline automatically wakes up, sends the build to Lambda Test, and runs dozens of parallel tests.
That's incredible. Okay, so we have the cross-platform scripts and we have the cloud infrastructure to run them. But there's one final piece of the puzzle.
AI.
Yes, how AI is stepping in to handle the visual nuances that code alone might miss. The sources highlight platforms like Apple Tools integrating with Appium and Espresso, using something called the ultra-fast grid for visual AI testing.
Right, because traditional code-based testing has a very specific blind spot. It checks logic, it asks the code if the checkout button exists, and if clicking, it works.
What if a junior developer accidentally pushed a CSS change that gave the checkout button a z-index error, causing it to render completely hidden behind a massive ad?
Exactly. The code still says the button exists. The Appium script will proudly report a pass because it technically clicked the hidden element.
But a real human user looking at the screen wouldn't be able to buy anything.
That's exactly why AI is tackling visual regression, checking if the app actually looks right, not just if the buttons technically work in the background.
And historically, pixel matching was terrible for this, right? It created false positives if an OS update slightly changed a font shadow.
Yes, it created massive flakiness, but visual AI uses computer vision models. It ignores pixel-level noise and focuses on semantic meaning, just like a human eye.
Okay, but this raises an important question. The Apple Tool source also dives into agentic automation. Does AI mean we won't need QA engineers soon? Or does it just mean they don't have to manually check if a button is 3 pixels out of place anymore?
If we connect this to the bigger picture, it's definitely the latter. AI in testing like self-healing tests and NLP builders is about reducing flakiness and noise.
So, like, if a developer changes a button's ID, a rigid script would crash. But an AI-driven self-healing test just updates the locator on the fly.
Exactly. It realizes the ID changed, but notes the visual appearance and function are the same. It empowers QA teams to focus on complex user scenarios rather than maintaining brittle test scripts.
Okay, wow. Let's pull all these threads together. Choosing the right tool depends entirely on your project, right?
Totally.
If you need raw speed and you're only building for one platform, Espresso or XCUITest is your go-to.
Right, and if you want cross-platform flexibility and broad language support, you choose Appium.
And to scale it all, you plug it into a cloud farm like Lambda Test.
Yeah,
It's a deeply interconnected stack.
it really is. But I want to leave you with a final thought inspired by that mention of AI agentic automation.
It'll lay it on me.
We've talked about using AI to test static apps where we inherently know what the interface is supposed to look like. But as apps themselves become more dynamic and AI-driven, actively changing their layout and features uniquely for every single user based on their behavior, how will rigid automation scripts keep up? In the near future, will we have to unleash AI testing agents just to test our AI-generated apps?
Whoa. That's a staggering thought. Like,
Yeah.
literally AI testing AI-generated experiences in real time. I love that.